How does entropy change in open systems? Have you ever wondered how energy and matter interact in our world? Today, we are going to discuss a fascinating concept: entropy in open systems. This topic is essential for understanding how energy flows and changes in various environments. First, let's clarify what we mean by open systems. Unlike closed or isolated systems, open systems allow both energy and matter to flow in and out. This flow is what makes the study of entropy in these systems so interesting. When heat enters or leaves an open system, it directly impacts entropy. The change in entropy is proportional to the amount of heat transferred divided by the temperature at which this transfer occurs. For example, if heat enters a system at a specific temperature, it brings with it a certain amount of entropy. Conversely, when heat exits, it takes away entropy in the same way. Now let's talk about mass flow. When matter enters or exits an open system, it also carries entropy. The change in entropy due to mass flow is determined by the mass flow rate multiplied by the specific entropy of that matter. This means that the matter itself contributes to the overall entropy of the system. In addition to these transfers, there are processes within the system that can generate entropy. These processes include friction, mixing, chemical reactions, and heat conduction. Whenever these irreversible processes occur, they increase the total entropy of both the system and its surroundings. To put it all together, the total change in entropy in an open system can be calculated by adding the entropy transferred through heat and mass flow to the entropy generated internally. This relationship can be expressed mathematically as the rate of change of entropy equals the sum of entropy transfer by heat, entropy transfer by mass, and entropy generation within the system. In practical terms, this means that open systems can exhibit complex behaviors regarding entropy. Take a power plant, for instance. It receives fuel and air, which are forms of mass that contain entropy. It also releases heat and exhaust gases, which carry away entropy. Understanding how entropy changes in such systems helps engineers design more efficient operations by minimizing entropy generation and managing the flow of entropy effectively. So, when we think about entropy in open systems, we see that it is not just about disorder. It is also about how energy is available to do work and how natural processes unfold. This understanding is vital for anyone interested in thermodynamics and its applications in real-world scenarios.